Hello everyone, thank you for tuning in to my talk on secure development, where I will be telling you how to secure the code that you copy and pasted from Stack Overflow. So first a little bit about myself. My name is Gerben Klein. I'm originally from the Netherlands. I moved to the United States in 2009. I've been with Bishop Fox since 2014, where I lead security programs for our clients. I manage a team of consultants as well, and I try to break into systems and applications. I have a couple of industry-relevant certificates, such as the CISSP from ISC², as well as the OSCP and OSWE from Offensive Security. So today I will be talking to you about these points, the elements of secure development, knowing your tech, writing secure code, and then going a little bit beyond secure code and what else you can do to secure your applications. So first, let's talk about some of the elements of secure development. And I will really touch on this at a very high level. I don't want to get too deep into it because I want to focus mainly on the secure coding piece. But it's important to understand that creating a secure application is not just writing secure code. There's more that goes into it. And so here we have an overview of the secure software development lifecycle. And what is important to understand here is that you have to include security into each element of this life cycle. So from the moment you start thinking about your application, when you start defining the requirements, to when you start designing it and when you start writing the code, and when you test it after you're done writing the code, you have to take security into account for all of that. So you have to define security requirements. You have to think about what sort of information you're collecting, whether users should be able to access that information or modify that information, and you have to come up with a security model around that. So it's important to understand that security starts at the very beginning of an application, and it plays a part throughout the entire development process. It's not just writing secure code. So let's take a look at an example of what can go wrong if you don't take security into account at each stage of the development cycle. So this is an example, a physical example. This is not a software project, but I think it's a good demonstration of not taking security into account. So let's take a look at this security cabinet, right? It's meant to probably contain medication. And then it has a keypad so that, children and people, guests aren't able to get into this cabinet. Now, that's the whole purpose. It's to keep your medication secure, right? So let's look at a major security flaw here. It has two hinges with screws that are clearly exposed. So even if you don't have the combination to this cabinet, you can just take a screwdriver and take off the hinges and open it. Now, secondly, if we look at the inside of the cabinet, there is another security flaw. So it's not maybe, I hope you can see it okay, but there are screw holes that have little slots. So it's easier to mount this cabinet onto your wall. You can just sort of like slide it in. But that also means that even if you don't have the security code and you don't have a screwdriver, you can also probably just slide it off from the wall and carry it with you, right? And so the design here really fails at its objective of keeping your medications away from people who shouldn't get access to them, right? There are basic sort of security flaws that anyone can use to bypass the security mechanism. So use this as an analogy for your software project and think about ways that an attacker might bypass your security mechanisms. So let's talk about knowing your tech, which is really sort of the foundation to writing secure code. So you have to really understand the programming language that you're working with, as well as the framework. So for instance, looking at programming languages, there are certain functions that might not be safe to use, or maybe you shouldn't use them in particular cases. So for instance, in C, there are certain functions such as strcat and strcpy that can result in buffer overflows if you use them wrong. Similarly, if you're coding in PHP, there's a difference between a loose comparison operator and a strict comparison operator, and using the wrong one can potentially lead to what is known as a type juggling vulnerability. And so it's really important that you know the nuances of the programming language you're working with, because otherwise it's very easy to introduce unintended vulnerabilities. That also goes for your framework. So let's say I have an example here, Ruby on Rails is a framework that does certain things for you behind the scenes, so that when you're writing your application in Ruby on Rails, there are certain things that you don't have to think about because Ruby is doing that for you behind the scenes. But if you don't understand exactly what things Ruby is doing, you could unintentionally introduce a security flaw into your application. And we're going to take a look at a specific example of that. So this is from 2019. This was a bug that was reported to GitHub with their OAuth flow. So it was possible to bypass that, and GitHub ended up rewarding a $25,000 bounty for this, which was the highest at the time that they had ever awarded, because it was a very serious security bug. So let's take a look at two pieces of code. First, this is sort of the code associated with the router that takes care of this endpoint that you see there. So /login /OAuth/authorize. So when you go to this endpoint, the browser submits a GET request, and it gets sent to this function here in the controller. And so if this function receives a GET request, it will serve an authorization page that says, hey, do you want to link this app to your GitHub account? And then if you say, yes, I approve, that would send off a POST request in order to grant that approval. Now, if you look at the top piece of code, you can see that it's written in such a way that it should only ever forward a GET request or a POST request. So when you get to that second piece of code, the only two requests that should ever end up there is either a GET request or a POST request. And you can tell that the developer thought the same thing, because they wrote an if-else statement. If this is a GET request, do one thing. If it is, or else, right? Else, do something else. And the else statement is supposed to only catch POST requests, because those are the only two requests that should ever make it here. But Ruby on Rails does certain things behind the scenes to make life easier. And so let's talk about head requests. So a head request is a GET request where the server only returns the headers and not the body of the response. And so this is useful, for instance, when you're trying to download a file and the browser first wants to check how big that file is before actually starting the download. Now, to sort of make it so that developers don't have to write code for head requests, it's just treating head requests like GET requests, right? It's just doing the exact same thing, but then at the very end, Ruby on Rails just takes away the response body and only returns the headers to the user. And you can probably already see where this is going, because now if we look at that code again, so the developer thought that it would only ever deal with GET requests and POST requests, but because of the way that Ruby deals with head requests, those actually also end up into that piece of code. So now we have GET requests, POST requests, and head requests. And so it checks if the request is a GET request, do one thing, and else do another thing. Well, a head request is not a GET request, so that's going to fail, and it's going to go into the else statement, and it's going to grant permission to the app, even though the user never actually specified that they wanted to do that. So by sending a head request to this endpoint, the user can bypass the OAuth flow. So that was a serious vulnerability that was introduced because of the way that Ruby on Rails deals with head requests. So let's talk about how to secure your code a little bit more. So I have a couple of quick sort of rules of thumb here. So first of all, always distrust user input. This includes, HTTP parameters, but also things that you might not think about, such as request headers. It includes files. It includes URLs. It really includes everything the user could possibly touch. And this is really the most important tip I can give you for writing secure code, because if you take care of this one, that really sort of eliminates 90% of security vulnerabilities, I would say, because most vulnerabilities are because the user is able to influence a variable or a parameter that they should never have been able to influence in the first place, right? So always distrust user input. Now, to kind of go along with that, always use parameterized SQL queries. This is sort of a defense in depth method. So if you distrust user input, then we can sort of assume that your SQL queries will be safe, but you can just use parameterized SQL queries and you will always be sort of safe from injection attacks. A third tip is to always HTML encode your output. So when you provide HTML to the user, just make sure that you sort of escape all those special characters so that even if the user inputs a cross-site scripting payload, it doesn't actually get rendered as HTML. It just gets rendered as sort of plain text. So it sort of eliminates those client-side attacks. The fourth tip is whenever you can, use an allow list instead of a deny list. So this we see this a lot of time in file upload functionality. So developers might create a list of, or they might have an idea of the types of files that they want users to be able to upload. And what they do is they create a deny list, basically saying any of these other files you are not allowed to upload. But a better way of doing that is to simply define which file types a user should be able to upload and then just deny everything else. Because otherwise, chances are you're going to forget one, or if new technology comes out, now you have to update your deny list. It's typically just safer to specify what you do want and then deny everything else versus trying to sort of figure out what you don't want. And then lastly is to always check open source libraries for vulnerabilities before using them. And we'll talk a little bit more about this one at a later slide. So let's go a little bit beyond those sort of basic tips and talk about other things you can do to secure your code. So first of all, make sure that you always understand every line of code that you're writing. So again, let's say that you have a problem and you post a question on Stack Overflow. That's totally fine, right? Like as programmers, we don't always know exactly how to solve every single thing. So we Google stuff and we go to forums and we post questions, and all of that is totally fine. But when someone provides an answer and the answer is exactly what you were looking for, so you're going to use that piece of code that they provided, don't just paste it into your code base and think that it's fine, right? You might think, well, it works, so it should be fine. But you really have to understand exactly what that code is doing, because if you don't, chances are that you might introduce some vulnerabilities that you didn't know existed just because you didn't understand exactly what that code was doing. So, so this one's very important. The next one, another safe coding practice, is to write explicit code instead of clever code. So what I mean by this, clever code is, let's say you write a function and the function handles a lot of different use cases, right? So like different parameters you can feed into it, and based on whether you feed it a string or an integer, it's going to do different things. Maybe you can either feed it like 2 parameters or 4 or 5 or 6 or 10. You're writing a function that does a lot of different things depending on how the user uses that function. And you might feel really proud about how you wrote that. The thing is though, like the more things your function does, the more use cases you have to account for, and chances are that you're going to forget one. And maybe the user can do something that you didn't think they would be able to do, but because your code is so complex, you didn't really think about it, right? And so whenever you can, write simple code. If you can make a function do a single thing, that's typically best. I understand that that's not always possible in complex applications, but you want to just kind of keep it as simple as possible. And a good sort of rule of thumb here is if you look back on your code after 6 months and you don't really understand what it's doing, then chances are it's probably too complex and you might need to refactor that code. Using safe defaults. So you want to write code that is sort of safe by default. You don't want to put it on the user to make your code safe before they can use it, right? And so let's look at an example of sort of how you don't want to do that. So in Node.js or Express, there's this app.listen, right? In order to start listening on a port for your application. And if you feed that one parameter, so in this case, a port number, then it starts to listen on that port. But by default, it listens on all interfaces, right? It listens for connections from anyone on the network. And arguably, it would be safer if by default it only listened on the loopback address, right? So you can only connect to it from your system without opening yourself up to the network. But in order to do that, you have to feed it a second parameter. You have to say app.listen on port 4000 and on IP address 127.0.0.1. So here, in order to make it safer, we have to actually take more steps, which is sort of the opposite of what you want to do. Now, this example is used just for illustrations. There are reasons why this function works this way, but I just want you to sort of like think about making your code safe by default. Code defensively and verify your assumptions and fail early. So kind of looking back at that code that we looked at before, if the developer had coded defensively, then they might have written a different statement. So instead of writing an if-else statement, they could have written if-else if, and then else. So basically saying, if this is a GET request, do one thing. If it is a POST request, do another thing. Otherwise, crash the application, because this should never happen, right? Because you should only ever get a GET or a POST request. And so when someone would send a head request to try to bypass this OAuth flow, the application would have crashed. Even though the developer didn't think this was possible, they put code into place to deal with it anyway, right? So it's usually preferable to crash your application than to try to keep going and introduce security vulnerabilities. So code defensively, verify your assumptions, and sort of like write code for all cases, that even the ones that you might not think could exist, and that will typically eliminate some of those security vulnerabilities that you didn't even know about. So those are some secure coding practices. Now let's talk about other things you can do beyond writing secure code, because even if you write secure code, right, your application is written in 100% secure code. Now, I don't know if that's possible, but just for the sake of argument, let's say that that's the case, right? There are still vulnerabilities that could occur. So for instance, let's talk about subdomain takeovers. So one way in which subdomain takeovers happen is you fire up a server. Let's say you use a cloud service, right? And you fire up a server and you create a DNS record that points your domain name at your IP address. Now, let's say that you switch cloud providers, and so you decommission that server, but you forget to remove your DNS record. And now another user from that cloud service can spin up a server, and they might get the same IP address that you used to have. So now you have a DNS record that points your domain name at someone else's server, and they can take it over. Basically, that's a subdomain takeover. And so that has nothing to do with writing secure code. Like, your application might be secure, but you still have a vulnerability because of issues in your infrastructure. And so this happens all the time. We see a lot of subdomain takeovers. For instance, in 2018, someone was able to take over registry.node.js.org, and within that short period of time that they had taken that over, they received a lot of requests for installations of NPM packages, because they were all going to the wrong place. And so they actually were a white hat hacker, and they reported this, but if they had been malicious, they could have installed malicious code on people's systems. Another thing to be wary of is supply chain attacks. So most software projects are not written 100% from scratch. You typically use imports and libraries, dependencies, and we tend to trust these because they are usually they are open source, and they are publicly audited, and you can look at GitHub and look at all the sort of merge requests, right? And so we just sort of trust that these dependencies are secure, but that's not always the case. In 2018, there was a particular package called EventStream, and malicious code was found inside of it. And it was very specific code. It would only fire under very, very specific conditions. So like 99% of the people who used this package actually weren't vulnerable, but 1% was. And it actually led to some exfiltration of Bitcoin wallet keys. So yeah, that was a real thing that happened due to a supply chain attack. Another example is in 2016, a German student. In 2016, a German student used a variation of typo squatting. So typo squatting is where you register a domain name that's similar to another domain name. So let's say that you register pacebook.com instead of facebook.com. And so if someone mistypes and they accidentally type Facebook, they actually go to your website, right, instead of Facebook, where they wanted to go. And so this student used the same technique to register software packages that had a name very similar to some other popular packages. And he found that a lot of users actually misspelled the package that they wanted to use, and they ended up installing his package instead, which in this case wasn't malicious because he was a researcher. He wasn't doing it for malicious purposes. But if an attacker did that, they could execute code on your system. So so those are examples of things that you have to be careful about. You have to make sure that in addition to secure code, you also secure your infrastructure. And this kind of goes back to that whole taking security into account during the entire development process. And also for defending against these attacks, code audits aren't going to help you. So in this case, you want to use a combination of, for instance, application sandboxing and network policies. So that, for instance, if you accidentally install malicious code, right, through a supply chain attack, and it tries to fire off a reverse shell to the attacker's system, then hopefully you have some network policies, firewall policies that will prevent that from actually succeeding. So yeah, those are my tips on how to create a secure application. Finally, I want to just draw your attention to the Capture the Flag that's happening on June 9th and June 10th, where you can complete some challenges in order to try to win some cash prizes. And the challenges will be fun and also educational. So make sure to register at that link displayed at the bottom of the slide. And that is all that I have for you today. Thank you very much.